Okay, it is Advanced Math Trig Honors Class, Mods 2, 3, and 4. Today is Wednesday, April 15th, 2020. So, top left corner of your paper, today's date is 4/15/20. The title is Exponential Equations. Now, since the title is Exponential Equations, obviously every problem we're going to attempt today is going to be an equation, have an equal sign. There's going to be a variable of x that we've got to solve for, but that variable is a missing exponent. Oh, so if I ever have an equation and there's a missing exponent or exponents involved in the equation that we're trying to solve for and isolate, it's called an exponential equation. So 415, exponential equations. If you look on your Schoology, there is a reference sheet or a supplemental sheet that you can refer to or print out. It is a worksheet that Mr. DeMarco left that has 32 questions on it. Okay, you can kind of see it right now. I've got it on the screen. It goes from 1 to 32. Again, it's listed or given to you on Schoology so you can look at it, print it out, use it if need be. But the goal is this. Since there are 32 of them, we are going to do today in our note-taking session 1 through 15 odd. So we're going to do 8 problems. 1, 3, 5, 7, 9, 11, 13, and 15. Your homework is going to be that worksheet that's again on Schoology, and you'll have 2 to 16 even. Tomorrow, on Thursday the 17th, I'm then going to do 17 through 31 odd as the questions we're going to attack and do in our notes. And those, of course, will mimic your homework, which will be 18 to 32 even. Okay, so in the course of 2 days, today Wednesday and tomorrow Thursday, we'll have all 32 questions done. I'll do 8 in notes, you'll do 8 for homework. Then we'll look at the bottom half of the sheet. I'll do 8 in our notes and you'll try 8 for homework. Okay, these are all exponential equations. We will then have a similar worksheet on logarithmic equations beginning on Friday. Okay? All right, today, here we go. Block number 1. This is problem number 1 on that worksheet. I will forewarn you, you gotta have your calculator out. So graphing calculator in hand. Problem number 1 says e to the x equals 10. So obviously, if you look at the equation, we're thinking if I take e, I would raise it to what exponent? What's my missing exponent here? And I want to end up with an answer of 10. Now let's just use a little common sense and try to guess at an answer here real quick. Remember when you see a base of e, that's what, 2.718? And I'm raising it to what power to end up with an answer of 10? Now obviously if that was e to the first, the answer would end up being 2.718. E to the second, since 2.718 rounds off to almost 3, even 3 to the second would be 9. So my guess is that this missing power of x has got to be over 2, probably 2 point something. Okay, guys, here's the main step that's going to be involved in most or many of these equations. If you are ever solving an exponential equation with a missing exponent, your job is to log both sides. I always use the expression, when in doubt, log it out. I have some doubt as to what the missing exponent is. And since it is a missing exponent, and logarithms are the study of exponents and things you can do with them, I'm going to log both sides. Which is legal, right? Because the rule for equations is what? Whatever you do to one side, you do to the other. Now, because it's a base of e here, when I do say, let's log both sides, we're actually going to ln both sides, right? Because we use natural logarithms when the base of e is being utilized. So here we go. Step number 1. ln of e to the x equals the ln of 10. I natural logged both sides. Whatever I did to one side, I did to the other. Now, our exponent rules. Remember, we condensed and expanded exponents using our 3 rules? Does everybody agree that an exponent on a log problem is allowed to get moved to the front, isn't it? So if I take that exponent and move it to the front, I'm going to have x ln e equals ln of 10. And good news, we said this and emphasized it the last couple of days. If you ever see ln of e, remember ln of e is really the number 1. I guarantee it. If you took your calculator right now and you typed in ln and hit the e button, it would say 1. So since this ln of e is really the number 1, we can cross it out and ignore it because it's just a 1. Leaving that 1 dot connected to this x, so the missing exponent is literally ln 10. So guys, pull out your calculator, type in ln 10, hit enter, and to the nearest 3 decimal places, we're going to end up getting 2.303. Remember I predicted that the answer was a little bit bigger than 2 point something? It is indeed 2.303. And when we do our application problems at the end of the chapter on growth and decay and even some compound interest banking questions, they always traditionally, when solving exponential equations, round to the nearest 3 places. Okay? All right, let's scoot through this pretty quickly now. Number 3, you would find this on your worksheet. 2e to the x equals 39. Now, guys, if I compare that to the one I just did, the one on the left had e to the x by itself, so I probably want to get this e to the x by itself, okay? Do not log both sides yet. You don't log both sides until the base and the exponent is by itself, okay? If it said e to the x equals 39, yes, I would log both sides because I'm trying to isolate a missing exponent. But hey, that is a dot connected to. Let's divide by 2. The 2's would cancel. I have e to the x equals, what is that, 19.5, right? 39 divided by 2. And I'm back to the same position I was over here. So I'm going to, when in doubt, log it out. I'm going to natural log both sides. ln of e to the, you might as well not write the x up there because you know you're going to move it in front anyway, agreed? Equals ln of 19.5. Don't forget that. If I ln the left, I got to ln the right, okay? ln e I can ignore because it's really a 1. So in essence, I've already solved this. I'm literally just typing in the ln of 19.5 and getting 2.970. So 2.97 for my missing power. Okay? Problem number 5 on our worksheet that again is found on your Schoology page. You can print this out, have all 32 questions right there in front of you, or refer to it if need be. Well, once again, do you agree we got to get this e to the x by itself? So big deal. Let's shove over the 5. I've got e to the x equals 15. Now that I've gotten a base and an exponent by itself and I'm seeking a missing exponent, I'm going to log both sides. Again, because I see it's a base of e, I'm natural logging both sides. So ln of e to the x power, I'll take that power and move it out front, equals ln 15. I natural logged both sides. The ln e is ignored because it's a 1. And all I'm doing on this one is typing in ln 15, hitting enter, and my calculator says 2.708. Bam, 3 for 3. And finally, the last one, 7 minus 2, e to the x equals 5. This is number 7 on that worksheet. Once again, we're trying to get e to the x by itself, so let's minus over our 7. I end up with what? Negative 2 e to the x equals what? Negative 2. Divide by negative 2. Those would cancel. I am now at this point, e to the x equals 1. Okay, guys, freeze. Yes, if I wanted to, I could now proceed by natural logging both sides and doing the same thing we've been doing. But think about it. Do I really need to do that on this question? You're allowed to use common sense sometimes. E raised to what power would give me 1? Remember the golden rule that we've said for dealing with exponents our whole lives? Any base, no matter what it is, even if it's an e, if you raise it to the 0 power, you always get what? 1. So it's pretty obvious here. We can simply write x equals 0 and we're done. I'll be darned. Okay? Continuing on our worksheet, we're on problem 9. Again, I'm doing 1 to 15 odd. Your homework is going to be 2 to 16 even. Number 9. Now we've got a 3x for our missing exponent instead of just an x. Well, so what? That's not a big deal yet. Do you agree that because it is a missing exponent, even though it's a 3x instead of an x, okay, I'm going to still follow the rule, what? When in doubt, log it out. Because my base, again, is an e. E is going to be the base of all the problems today. If you look at the bottom half of the worksheet, we go to different bases other than an e. So for today, again, we're going to natural log both sides. I'm going to have ln of e to the 3x equals ln of 12. Whatever I did to one side, I did to the other. I natural logged both sides. This exponent goes out in front like we've been doing. So I have 3x ln of e equals ln of 12. The ln e is irrelevant because it's really a 1. So do you agree to get this x by itself? I'm now going to divide by that 3. Now, guys, careful. When you go to your calculator, you've got to enclose the parenthesis around the 12. Watch this. When I type ln 12, if you just hit divide by 3 without closing the parenthesis, you will not get this right. So careful. I always like to hit the ln 12, the top value, hit enter, then hit divide by 3 so I don't forget to type in that parenthesis each time. So I'm typing ln 12, I hit enter. Oh, now that I've entered that, I'm going to hit divide by 3. Final answer here looks like 0.828 to the nearest 3 places. Okay, number 11. Again, I've got an e raised to a missing exponent. We want to get that thing by itself, don't we? There's a dot connection involved, so would you agree we're going to divide by 500 in our first step? The 500s cancel. I've got e to the negative x equals, well, I'm pretty sure if I hit 300 divided by 500, I get 0.6. And now I'm to the point where I've gotten my base and my missing exponent by itself so that I can now naturally log both sides. So I'm going to ln both sides. So I've got ln of e to the negative x. That exponent, of course, is going to go out front, equals ln of 0.6. I natural logged both sides. ln e I can ignore because it's a 1. If my goal is to get x by itself, of course, I divide by negative 1. And x would be, okay, again, I'm going to hit ln 0.6. I'm going to hit enter. And then divided by negative 1, I'm getting an answer of 0.511 when I round it. Make sure you're getting that on your calculator for the nearest 3 places. Okay, 2 to go. You're doing great. Number 13. Oh boy, look at this. It says 3e to the 3x over 2 equals 962. Oh boy. Oh, well, wait a minute. I'm trying to get that by itself. Agreed? So I'm going to divide by 3, divide by 3. 3's cancel. I've got e to the Now, guys, let's think about this for a minute. If that says 3x over 2, isn't that really 3 halves dot connected to an x? Isn't 3 halves x the same thing as 3x? Now, why am I pointing that out? If that's really 3 halves x, I might as well just make it 1.5x. And on that side, I've got 962 divided by 3, giving me, it looks like 320.6666. So I'm going to go 320.6, and I'm just going to put a bar over it. And now I've got my e raised to my missing exponent. Of course, I'm going to ln both sides like we've been doing. So I've got ln of e to the 1.5x that's going to go out in front. If I natural log the left, I got to natural log the right. Boom. And now the ln e is irrelevant because it's really a 1. And to get that x by itself, I can divide by 1.5. And x would be, okay, I'm going to go ln of 320.66666, hit enter, then push divided by 1.5 and get. It looks to me like it's 3.847. Okay? And finally, the last one I'm going to do, number 15. Oh, finally, they challenge us with a much tougher looking problem. Okay, first of all, guys, if you looked at this, I'm going to give you a minute to think about this one. And I said, what would you do first on this equation to try to solve for the missing value of x? Most of you would probably add over the phi like we've been doing and move it to the other side, but then you'd be stuck with this on the left, and there's really no way to combine like terms here because one exponent is a 2x and the other one is an x. So what the heck are we, oh, wait a minute. Let's think about this. Would you indeed describe everything on the left as a trinomial, and notice it's equal to 0? So I've got a trinomial equal to 0. My instincts are telling me, why can't we take this trinomial and try to factor it into two binomials? I'm going to factor this trinomial. Since that says e to the 2x, wouldn't that be e to the x times e to the x? Because think about it, guys. If I take e to the x times e to the x, anytime I multiply two like bases, isn't the rule add the exponents? So if I added an x plus an x, I would get 2x. So that actually makes sense when you think about it. I have a minus at the end, so my signs are different when I factor this. And since my middle number is a -4, wouldn't I use a +1 and a -5? And a +1 and a -5, when added, give me the -4. It matches the number in the middle, and my trinomial actually successfully factored. Now, because they're dot connected, right, I can do the old, let's split those factors apart and set them both equal to 0. So I've got e to the x plus 1 equals 0, e to the x minus 5 equals 0. To finish this, I'm going to minus over the 1, get e to the x equals -1. Here I get e to the x equals 5. Okay, freeze. Look at this scenario right here. Think about it. I'm going to give you 10 seconds to think. What do you think the missing exponent is in this problem? If I take e, which is what, 2.718, what power would I raise it to get an answer of -1? Isn't that impossible? Think about it. If I take 2.718 and I raise it even to the 0 power, I get 1. If I raise it to any positive power, it's going to be a positive answer. And even if I raise it to a negative exponent, I don't produce a negative answer. I just flip my answer over and get decimals. Agreed? So this is actually an impossible situation. There is no missing x that would create an answer of -1. So there's no solution to the problem yet based on that scenario. However, right here, I think we can get an answer by doing what we've been doing. I'm going to natural log both sides, get ln of e to the x, put the x out in front, equals ln of 5. Since ln e is really a 1, I can ignore it. And x, the only answer to this problem, is ln of 5, which on my calculator gives me 1.609. I did it. So basically, guys, we just did 1 through 15 odd, and they are all what? Exponential equations with missing exponents, and these all had a base of e, okay? And the reason that Mr. DeMarco, I'm pretty sure, wanted you to start out by doing all of them with just a base of e is because the value of e has so many real-life applications, especially in science with growth and decay formulas. We're going to see that in a few days when we do some growth and decay problems. And because the base of E is such a popular base in those types of problems, it was good practice to practice solving some exponential equations that add indeed a base of E. So your homework, which is going to be due tomorrow on Thursday at noon, right, would be 2 through 16 even on the worksheet that I did attach to Schoology right with today's day of notes, okay? Great job. Tomorrow, I'm going to do 17 to 31 odd, and your homework will be 18 to 32 even to finish out the rest of that worksheet. Thanks, guys. See you then.